Today we're wrapping up the series with our final lab configuration demo. In this video, we're setting up IPsec and taking a look at how it keeps traffic secure when it moves across untrusted networks. We'll talk through the main pieces that make IPsec work and see how it fits into the overall design we've been building. Before we get into the lab, let's talk about what IPsec actually is. IPsec is basically a way to protect your traffic when it has to travel across networks you don't fully trust. Think of it as creating a secure path so your data stays private, verified, and untouched while it moves from one device or site to another. It does this by combining a few important security functions. First, IPsec uses encryption to keep your data private, so even if someone intercepts the packets, they can't read them. It also makes sure both sides of the connection can prove who they are, which prevents impersonation. And finally, it checks that data hasn't been changed along the way, giving you integrity protection. To make all of that work, IPsec uses a negotiation process called IP to agree on the security settings and exchange keys. Once that's done, the two sides set up security associations, which are the rules for how the traffic will be protected. After that, ESP steps in to actually encrypt and validate the packets as they move across the network. In short, IPsec builds a secure tunnel across an untrusted network. It keeps your traffic private, confirms who you're talking to, and makes sure nothing gets tampered with. In today's lab, we're setting up an IPsec tunnel between branch 1 and branch 2 using IPsec version 2. We'll build out the proposal, policy, keyring, and profile, then tie everything together with an IPsec transform set and IPsec profile. Once that's in place, we'll apply the protection to tunnel 0 so all traffic between the two branches are secured. On branch 1, we'll point our IPsec version 2 configuration at branch 2's IP address and use a shared key for authentication. On branch 2, we'll do the same thing in reverse, matching branch 1's address and using the same shared key. Both sides will use AES 256 for encryption, SHA 256 for integrity, and Group 14 for key exchange. By the end of the lab, you'll see the full tunnel come up and both branches will be exchanging traffic securely over IPsec.